Alright, this is page 253, problem number 2, and it's a video solution for this because a lot of people said in the year I'm filming this that they struggled with it. So here's my initial picture of the situation. It's just kind of a rough sketch. This is supposed to be a leg, and then and like a leg that's in a cast. This is supposed to be like a kind of a pulley system where this hanging mass supports the weight of the leg. And then this is the center of mass of the leg, and this is a hip joint. And I've got a couple of things labeled. The first is that hip joint is meant to be the axis. So I think if you struggled with this problem, one of the things you struggled with is that you probably didn't make this hip joint the axis. You probably chose to make the center of mass the axis. That's not what you're doing here. Your leg rotates around this joint, and so the weight of your leg pulls down and exerts a torque around that axis because there's a force exerted at a perpendicular radius. Maybe I can draw that on there. Yeah, let's do straight line drawer. So there's this force of gravity there, and it's exerted at this perpendicular radius, this distance right here. Okay, and they give you that distance in the problem. They tell you that distance is 0.35 meters. And then there's also this tension force being exerted, and that's also exerting a torque, but in the opposite direction around that hip joint. And that tension force is being exerted at, I think this distance is like the distance to right there, where this tension force would be coming in and acting. Let's do that as a dotted line. That tension force is acting straight up this way, and that distance that I got underlined in blue, that's the 0.75 meters. Or sorry, 0.78 meters, my bad. That's that 0.78 meters. Okay, so all I did was say that if we want this leg to be at rest, which if you have some kind of damage to your leg, you'd probably like to keep it at rest, is that the torques acting on this leg have to be equal to 0. So I said that the net torque acting around the hip joint is the axis. That's what this says. Net torque around the hip joint has to be 0. And really it has to be 0 around any axis, but the hip joint is what they've given you dimensions for, so it's kind of set up to be that way. Well, the torques around that hip joint are the torque exerted by this gravitational force, which is ml, the mass of the leg, times g, times that lever arm distance, which I've got highlighted in red as 0.35 meters. And then we've got also the torque exerted by this tension force, but that torque's in the opposite direction, so I'm subtracting it. These two torques, the torque of the weight of the leg and the torque exerted by the tension, are fighting each other. They're not working together, and that's why I got a minus in there. So it's minus tension times that 0.78 meters. Okay. What I tried to do is I went ahead and solved for that tension force. And so I calculated my way down through here, and I think if I go back to mouse, I can scroll down and just show you that I calculated that tension and got it to be 67.3 newtons. All right, so that's how much tension needs to be exerted by that rope. All right, well, that tension force is the same everywhere in that rope because it's a massless rope, or at least that's how we're treating it. And so then I looked at this mass and said, well, this tension and this force of gravity have to be equal acting on this mass, this hanging mass. And that's what you were asked to find, is how big that hanging mass is. So I did net force equals ma on that hanging mass. Again, I want it to not be accelerating. So I said that tension force up minus gravity down gives you 0. So that tension has to equal mg. And we were supposed to solve for that mass. And so as we said before, that tension is 67.3 newtons. You divide that by 10 meters per second squared, you get that the mass of the thing is 6.73 kilograms. And that's the answer they had. So I think my most likely guess is that your trouble was not using this as the axis, but that's what you have to use as the axis. So hopefully that helps.